The observer pattern is one of those design patterns that once you see it, you'll notice it everywhere. It's the foundation of event-driven architectures, letting one part of your system notify multiple other parts when something changes, without tight coupling. By the end, you'll understand how it solves coupling problems, how it works under the hood, and we'll walk through real code examples. Let's dive in. Picture a shopping cart in an e-commerce system. When a user adds or removes items, four different parts need to know. The UI refreshes, analytics tracks behavior, inventory updates, and email services kick in for abandoned carts. Without the observer pattern, your cart code directly calls all these services. Hard-coded dependencies everywhere. Want to add a fifth service? You're modifying cart code again. That's the tight coupling nightmare we're solving. The observer pattern sets up a one-to-many dependency. Your shopping cart becomes the subject. It doesn't know or care who's listening. Your observers are the UI, analytics, inventory, and email service. When the cart changes, you call one method, notify, and every observer updates automatically. The cart isn't coupled to these services. Want to add a new observer? Just register it. Want to remove one? Unregister it. The cart code never changes. Here's how the mechanics work. The subject holds the list of listeners and triggers notifications. Observers define the update interface everyone implements. Concrete subject stores your actual state, like cart items. Concrete observers handle their specific logic, updating UI, logging analytics, whatever they need. The flow is simple. State changes, notify gets called. Every registered observer receives the update. Clean separation of concerns that makes your system incredibly flexible. The subject class is surprisingly lean, just 3 methods doing the heavy lifting. We're using a set for automatic deduplication and faster lookups. Attach and detach let you subscribe and unsubscribe listeners. The magic happens in notify, one loop, calling update on everyone registered. No conditional logic, no coupling to specific observer types. This subject has zero knowledge about what those observers actually do with the data, and that's exactly what makes it powerful. Now let's build actual observers. Shopping cart extends subject. When you add an item, it notifies everyone with event data. Email, observer triggers a notification. Analytics, observer tracks cart size. These observers have no idea the other exists, and shopping cart doesn't know or care what they're doing. You could add 10 more observers tomorrow, logging, inventory updates, fraud detection, without touching a single line of existing code. That's the observer pattern paying dividends. Where do you see this pattern in the wild? Everywhere. Every time you attach an event listener in JavaScript, that's observer. MVC frameworks use it. Models broadcast changes. Views listen and re-render. RxJS, Redux, React hooks all build on these principles. Stock trading dashboards, where one price update refreshes charts, updates portfolios, triggers alerts, and logs history simultaneously. Without observer, you'd have spaghetti code. With it, each component listens independently. Here's a distinction that trips people up. With observer, your subject directly holds references to observers. They're in the same process. Notifications happen instantly, like DOM events. Pub/sub throws a message broker in the middle. Publishers fire events without knowing who's listening. Subscribers pull from that broker, often asynchronously, sometimes across different services or machines. That's why pub/sub appears in distributed systems like Kafka or Redis, while observer lives inside your application. When should you reach for this pattern? It shines when state changes ripple through multiple components, like that shopping cart updating UI, analytics, and inventory simultaneously. Perfect for dynamic scenarios where observers come and go at runtime. But don't over-engineer. If you're just calling 2 methods in sequence, skip the ceremony. Watch out for performance-sensitive code. Notification loops add overhead. Observer gives no guarantees about delivery order or success. So if you need that reliability, look elsewhere. Here's what really matters. Observer gives you clean separation between what's changing and what's reacting. You scale by registering more observers. No touching core logic, but watch for memory leaks. If observers don't unsubscribe, they stick around forever. Decide early if you're pushing data in notifications or letting observers pull what they need. You'll see this everywhere. React hooks, event emitters, database triggers. It's one of those patterns you realize you've been needing all along. Ready to modernize more legacy code? Check out our next video on the Strangler Fig pattern. It's a game changer for gradually replacing old systems without the Big Bang rewrite.